Hello, and welcome to the fifth of our 8-week webinar series called Advancing in Predictive with Alteryx. Today we will be covering fuzzy matching, and before we kind of get started, just wanted to give some reminder of some dates coming up. Upcoming topics, we have our decision tree, crosstab and transpose, and time series. And again, all these webinars are Thursdays at 12 p.m. So if you're interested in any of these upcoming topics, we're really excited about them. Go ahead and register those. They will be located on the Technion website. And a few notes before we get started. Yes, this webinar is being recorded and the link will be available before the end of the week. And we will have a Q&A session at the end, but you are more than welcome to enter your questions in the Q&A panel as we go along. A few introductions. My name is Rachel Mason, and I'm the marketing specialist here at Technion Data Solutions, helping out with this series, and Technion is happy to be hosting.
Hi everyone, welcome back, and I'm Dina Sanchez, and thank you Rachel for the great introduction over at Technion and talking about all the wonderful series that we've been doing. So if you've been a part of this series, you just had a series with Dr. Kyle Roberts, who is our data scientist at Technion on K-means. And so today I'm going to pick up from there and talk to you about fuzzy matching. But first, I'll give you a little background about myself. I am very privileged to be an Alteryx ACE, which is an Alteryx certified expert. And I've been using Alteryx since 2005, way back when, almost the last century there. My degree is actually in geography and GIS. And so I do specialize in spatial and demographic analytics. And if you are in the Dallas-Fort Worth areas, you probably have come to our user group meetings. So I am the co-leader of the Dallas user group for 5 years and founded the Fort Worth Alteryx user group last year. And our Dallas group is now over 370 members. So we are always looking for larger and larger venues to host our user group meetings. So very excited to be here today and to show you a lot more about fuzzy matching as part of the data prep and blending series that we're hosting through Technion. So as you see, data prep and blending in Alteryx is a portion of what Alteryx can do, and yes, it really does do it so well. Fuzzy matching is a part of that data prep and blending process. And so you may have seen the fuzzy matching tool and just had questions about it. How do you use it? How do you really set it up? And what are the parameters and the algorithms inside of this fuzzy matching tool? So fuzzy matching in Alteryx it's got a great tool. This tool is one of the best I've seen for fuzzy matching, and I've seen a lot of software. So it does have these really wonderful embedded algorithms, and I'll talk a little bit about those today as well. You can customize your fuzzy match process. You can decide how you want the punctuation to be stripped, for example. You can change your threshold for your match scores and so on. You can get that speed to insight, of course, with Alteryx, which runs blazingly fast in virtual memory. So it's one of the reasons I do my fuzzy matching in Alteryx. And you can also see the generated keys, which if you're a geek like me, you probably will be fascinated with how letters turn into code, turn into numbers, and then all of that's measured in algorithms, and then the fuzzy match process happens from there. So I'll show you a little bit about that. You can also fuzzy match using a waterfall approach, and I'll actually build a workflow today that shows you that process. So you'll actually first match on some embedded or set fuzzy matching algorithms, and then for those that didn't match, you do a waterfall approach and change your parameters and match again. So there's so much more to it. So I'm very excited to actually show you exactly what that looks like in Alteryx as well. So now I'll go ahead and switch over and show my screen there. So let's see, let me get the screen going here. And then I'll show my screen and I have Alteryx up and running. So here in Alteryx, I do have the join tool set showing. This is part of data prep and blending in Alteryx, and of course you've probably already seen the join tool in action, the union tool in action. If you haven't, and if you're really new to Alteryx, I actually have a webinar that I've done at Technion called Joins and Unions in Alteryx, very aptly named there. And you can actually access that on the Technion website at technionusa.com/videos, and then just look for joins and unions in Alteryx. I do a deep dive into both of these tools and some tips and tricks as you're using these tools as well. So along with joins and unions and even append fields, we have the very special fuzzy match tool. This is very powerful in Alteryx, and as I mentioned, very fast in Alteryx as well. So I'm going to bring in two data sets. This is, for example, some loyalty data. You can actually fuzzy match all sorts of data here. So you can actually match names, you can match addresses, zip codes, and so on. A lot of pre-programmed algorithms for your fuzzy match available in Alteryx. So I'm going to bring in some data here. I'm going to just go to a file. I'm going to pull in some 2015 loyalty data. And when I pull in the data, you can see here I've got a first name and last name, got an address, a city, state, and zip code. So with this, I'm going to try to match this to a second data set, and that second data set is going to be the 2016 data. So really, I'm looking to see what matched between the two data sets, which customers, for example, are continuing from 2015 into 2016. And also with fuzzy match, I can actually match in case things are misspelled. So that's really one of the beautiful things about the fuzzy match tool. If you've got, user error, as it is called, and names have been mistyped or streets have been mistyped, or even if a name has been typed in as a nickname, Alteryx has a solution for that in your fuzzy match tool. So before we actually do a fuzzy match on this, we actually need to prep the data a little bit and get it ready for fuzzy matching. So one of the best practices, whenever you have data coming in and you're doing any process in Alteryx, is to remove any unnecessary fields. You don't really need those fields later on in the workflow. They're really just adding additional data to your workflow that you need to process and run. So one way to do that is the very efficient select tool. So I'm going to bring a select tool to the canvas. And here I'm going to connect it to the 2015 data. I'm actually going to remove city and state because I don't really want a fuzzy match on city and state. Those are really very general geographies. It's not as precise as a first name or last name. And also when I'm doing the fuzzy match process, if I match on city or state, it's going to generate what are called keys to do the match. And these keys are part of those cool algorithms I was mentioning, where you actually take letters and turn them into a pattern, and then you see the similarities between the patterns. So if everyone in this data set lives in any town, USA, then that match is just going to be the same for everybody. So why not remove that, all these any towns from here? We know that those are going to match anyway. So I'm going to take the city and the state out of here. I'm actually going to do the same on the second one as well. Just take out city and state. I'm actually going to perform a match on first name, last name, address, and zip. So I can get much more precise matching and just take out any data that's unnecessary. So last week I was actually at the Alteryx Inspire Europe conference in London, and I was very privileged to present on this type of optimization of your workflow. Very honored to present with the very famous Marky Crew, or Mark Frisch, creator of the Crew macros, along with Adam Riley of Alteryx. And so Mark and I presented on ways you can optimize the performance of your workflow, and adding select tools as early as possible and taking out any unnecessary fields is one of the best ways to improve your performance of your workflow. especially if you're dealing with millions of records or gigabytes worth of data. Remove as much data as you can before processing, and that makes things very efficient. So the next thing I'm going to do is use this handy dandy data cleansing tool. This tool is very efficient. I'm actually going to use it on all the fields, and I'm really using it to replace or remove leading and trailing white space. Just in case there's anything going on in my data that I'm not aware of with the white space, I definitely want to remove this. I also want to remove white space because in some fuzzy matching, the space is considered a character. However, in a lot of the algorithms in the fuzzy match tool, you can remove the space as well and have it ignore that. So I'm going to remove this leading and trailing white space. I'm also just going to click Modify Case and make the data uppercase. This will actually make my fuzzy matching a little more efficient, a little faster. But I do want to note that the fuzzy match tool doesn't actually need this to happen. It actually will do a fuzzy match whether or not your data are all uppercase, lowercase, or title case. So you don't have to do the modify case before the fuzzy match. It will actually match anyway because it's looking at the characters and it's looking at how words sound. But I'm going to go ahead and do modify case just to put it in there. I'm going to do the same over here, very same thing, modify that to uppercase, and keep that a very fast process there. So there's two extra steps to do here, especially when you're comparing two different data sets, and you're going to do what's called a merge mode in your fuzzy match. It's essential that you have two items. You need a record ID, and the record ID needs to be unique between the two different data sets that you're comparing, and they need to be vastly different. So that's really the way that the fuzzy match tool actually tells the data sets apart. It also needs a source. So I'm actually going to add not only a record ID, but I'm going to add a formula tool and create a source for these data sets. So I'm going to have a source A and a source B. This also helps the fuzzy match tool realize where the data are coming from and what it needs to compare to. So I'm going to add a record ID here. And in this record ID, I'm going to just leave the default. It's going to be a record ID field, starts with 1, just an integer. It's going to be in the first column. Nice and simple. The next record ID is, I'm going to start here, and I'm going to make the starting value 10,000. This is going to be way above the number of records in this data set. So that way I can compare the two and know that my next record ID that's starting is actually a definitely different and unique record ID between the two. I'm going to keep it as an integer and first column so that my record IDs will line up. And then, as mentioned, I'm going to add a formula tool and add a new column called source. So this is essential when you're comparing two data sets. There is a mode in fuzzy matching called purge mode, which actually compares all the information in one data set, and you don't have to add this information. But for merge mode, you do need a record ID and a source. So I'm going to create a new column called source. I'm going to just call it source A. I'm going to actually leave it as a string, but I am going to change this size down from 1 billion, which is a good default size, so nothing gets truncated. And I'm just going to make it, say, a size 16. It's kind of nice and simple. And then I'm going to do the same with the next formula tool. I'm going to create a source here, adding a column, and then naming that column source. And then I'm going to call it source B. And same with my string, I think I'm going to make it a 16 with enough width there for that data there, source A and B. And then now that I have my sources set up and my record IDs, I'm going to add a browse so that I can actually look at my data and just see what this is looking like. I'm also going to show you a quick tip and trick for adding your browses. I'm going to swipe over both tools and then do Control-Shift-B as in browse. And now I've added a browse. So yeah, that's pretty cool, isn't it? I'm going to do that again just for fun. So swipe over both tools with them both highlighted, do Control-Shift-B, and now you've got to browse on each one. And they're perfectly aligned. For those of you who like to line up your tools in the workflows, these are aligned exactly right. So now I'm going to run the data. You can see I've got about 211 here, 298 here. Here is my information from the 2015 data, source A, simple record ID. And then here's source B with my unique record ID coming from that. So now I've got this data prepped and ready. So one thing about the fuzzy match tool, if you look at the fuzzy match tool, it has one input arrow. So that means it only takes one source coming in, one data stream. So this means you actually have to union your data before you feed it into the fuzzy match tool. So again, that's an essential process also. It doesn't have two inputs like a join tool. It only has one, so you definitely need to union that data first before you push it into the fuzzy match tool. So I'm going to add a union tool here. And again, you can see when I zoom in, the union tool has a double arrow for its input, and that means that it can accept more than one input. So any tool that's got that double arrow, such as the map input tool and so on, that means it'll take more than one input. But if it has one arrow, it can only take one input, such as the fuzzy match tool. So I'm going to union this together with source A and source B. And then in the union, it's really easy to, you'll probably hear this in my joins and unions webinar, really easy to just leave it as auto-config by name and assume that everything is lining up, but maybe it's not. So I always, no matter how small the data set, look at manually configure fields, and then I check my fields to make sure they're lining up. So here I've got primary address, and then I've got address. So I'm actually going to switch this over so that addresses line up. I'm also going to switch over to my zip code and move that over. So you can see I'm just moving these with the arrow buttons here. So now I'm making sure that everything is aligned. My addresses are in the same column. Certainly my source is in the same column, and that is important when I'm going to do my fuzzy matching. So now that I've got my union tool set, now I can perform the fuzzy match process. So I'm going to take a fuzzy match tool from my join category. And just as I mentioned before, there's only one arrow coming in. So that's why it's important to union the data first. And in my fuzzy match tool, here's the two modes that I was talking about. So there is a purge mode where there's all records from one source being compared. So you may have, say, a list of names, and you want to see if any names are duplicate, but also maybe there's nicknames in there or misspellings. You can run it through purge mode, and it compares all the records in the data set. In purge mode, it is important to have a record ID so that you can see what matches between the two, but you don't need a source field. For the merge mode, however, I do need a source field because I'm comparing two records or records from a different source. So here's my source ID field. I'm going to change that to source. I'm going to make sure my record ID field is record ID. And then I'm going to leave my overall match threshold at 80%. So I'll go a little bit deeper into what the overall match threshold is compared to the match threshold inside of each of the match fields. So they can be different actually. And these are so customizable. So as mentioned, you can go in and actually change parameters, really tweak and perfect your fuzzy match process to get it to optimize to the fuzzy match that you're looking for. But first, before we customize, I'm actually going to use just the embedded algorithms already in the fuzzy match tool. And these are really awesome. I congratulate the developers of this tool because they did a great job putting these algorithms in here. So first, I'm actually going to match on zip code. So with zip code, this will actually help me to put my match into that specific area of zip code. If I click on match style, I actually have a zip code algorithm already preset, which is really nice. I also have it preset for address, for company names, for names with nicknames, and so on. So if you do have a name field with the nicknames, Alteryx actually has a lookup table that it uses behind the scenes, and it matches those names to those nicknames, such as Mike and Michael or Jim and James. So it recognizes those as part of the fuzzy match process, which is really cool. So I'm going to show you very quickly a part of what this looks like with the algorithms. So if I click on Edit and I say zip code, you can see that in zip code, it's only going to use digits only. It's going to have a maximum length of 5. It's only going to match on the key matches, and so on. So the rest is grayed out here. This is separate just for zip codes. I can actually show you if I had, say, a company name. I'm going to say no, I don't want to change that one. The company name will strip punctuation. I can actually take off and, of, and the. I can use this for US addresses, which is really efficient. There's keys, and these keys are something I'll go into a little bit, but there's some great resources for reading about how keys are generated. And again, if you're a geek like me, you're going to find this fascinating. So I have spent many happy hours going down rabbit holes on Wikipedia, which I will show you, learning how keys are generated. So you have double metaphone, you have metaphone with digits, which is great for addresses, you have soundex, and so on. So all of this is embedded in this fuzzy match tool. The digits only reverse is great for phone numbers, because if you're fuzzy matching on phone numbers, your area code is the more general area. It's definitely for your main area code, say for the Dallas area. The next 3 digits are actually your city code, so it brings the generalization down to a smaller geography, but it's still kind of general. And then your last 4 digits of your phone number are your unique identifier. So it reverses those digits so that it can match on the most unique part first. So it starts with those last 4 digits and then moves all the way up to area code. And that's how it matches on phone number. So soundex is really great if you have a lot of foreign language terms. So if you have a foreign language company or foreign language names or and so on, use soundex, because soundex actually takes into account the way the word sounds, and it incorporates international words as well. So definitely use soundex for that. Metaphone is really how the words sound, especially in the English language when we're using these match options here. So you've got a lot of options here when you generate the keys. There's also the match function. So again, applause to the designer of this tool, because they got into the real algorithms behind the scenes of Jaro and Levenstein. So these are very cool. The way that it translates into keys and into numbers, and then it performs the match. So I don't have much time today to show you and tell you all about the difference between Jaro and Levenstein, but what I can do is actually show you Wikipedia. So feel free to look for Levenstein distance. This is in information theory, linguistics, and computer science. It is a string metric, and again, this is really fun to do if you've got a weekend and you don't want to binge watch all your favorite shows. You can actually learn about the Levenstein distance, which is actually pretty cool. So for the distance between words, it's actually showing how many turns it takes to actually switch one word to another. So to switch kitten into sitting, there's 3 turns. You have to change the K to S, the E to I, and then you have to add a G. So there's 3 turns into that word. So when you have the lower number of turns, the more similar the words are to each other. So if you took my name, Dina, and you compared it to James, there's a whole lot of turns to actually switch between my name and James if you're switching one character at a time. So since it's a high number of turns, you can be pretty sure that these two words, Dina and James, are not similar. So that's really how the Levenshtein distance is working. Of course, there's a lot more to it than what I've just talked about. But feel free to actually peruse this. There's also the Jaro-Winkler distance, and you can read about this. These designers, Jaro-Winkler and Levenshtein, really geniuses when it comes to looking at characters and how things are similar and how they're different, using mathematics throughout. So with that, we'll go back to Alteryx, and now that you've seen what's going on with the algorithms inside of this, then you can start to understand how the fuzzy match is happening. So I'm going to keep this one as zip code. I'm then going to switch over to address, and I'm going to just use an address for my type of match. If I click on address in the edit, you can actually see what's going on there. It's going to strip the punctuation, make a maximum key of 8. It's going to use words and digits with a Jaro distance. The reason it's using digits along with words is for those house numbers at the start of your address. So it's going to compare those two. We have an option for US address here, which is nice. And then when I add the name table, you'll see the nickname table there. I mentioned the thresholds. So the threshold for my address process is 85%. My weight is at 100, so I want address to be a very highly weighted match. But my threshold's 85, so this gives some wiggle room. So if things are spelled slightly different, then they're going to have a match. If I make it a match threshold of 100%, for example, then it has to match exactly. And that kind of removes the reason for my fuzzy matching. I might as well just do a join at that point. But I'm going to keep it at 85 so that things that are not the same, but only slightly off, will actually match. And you'll see what that looks like after I perform the fuzzy match. So I've got my address here, and then I'm actually going to do first name. So on first name, I want to do name with nicknames. And this is going to use that nickname table as well. And then I'm going to do last name. So with last name, I'm just going to do name. You normally don't substitute nicknames for last names there. So now I've got my match process set up. I'm going to, in my advanced options, do an output match score and an output generated keys. So this will help you see what those keys look like when they come through. And there's something really cool about the keys. And again, that goes back to those Wikipedia pages of Jaro and Levenshtein. So I'm going to add a browse tool here, and I'm going to run through the fuzzy match process. So it found 91 in this first pass that actually matched together. So the way you look at this is record ID 16 has matched to record ID 1021. It's got a score of 100, and here's the keys. So we'll look deeper into the keys at the end when I join the data back to the original source. But the cool thing is that the researchers found that in the American language and in most human language, most letters can be broken down into sounds that we really have only, I think, about 12 or 16 basic sounds in especially the American language. And you'll see how that works. So like a hard C in cat is very similar to the hard K in kite. So when the keys are generated, that hard C and that K are actually given the same match key. It's basically saying this is the same sound, this is the same key. So it's really neat to go through and look at the keys and see how the algorithms are actually matching these together, which is really fun. But first, now that I've done a match, I want to make sure each of the matches are unique. So I'm going to bring this down because we do have multiple matches based on parts of the address, for example, that it matched to. So we might have state and parkway. It's going to make keys for state, and it's going to make keys for parkway. So to make sure it's unique, I'm just going to add a unique tool here. I'm going to say, give me a unique record ID, and then I'm going to add a browse after that. That way I can see my unique numbers. I brought it down from 91 to 71. And so here are all my unique ones with the unique record IDs. So that's just a best practice. You can keep the others, but you basically have the same record ID with the multiple matches there. So once I found how many are unique, I'm going to assign a grade or a match status for this. So I'm going to say, let's give a formula with a new field, and we're actually going to call this field match level. So I'll just say this is my match level of 1. This is my first pass of the actual fuzzy matching. Just going to give it a match level of 1. I'm going to change this data type to a double just to make it a numeric field there. And so that'll be my first pass, and I'm actually going to keep that as a label there. So now that I've actually got this grade here for exactly what the process is, I'm going to view the results, look at my grade, and say, yes, this is first pass 1. I actually like browse tools a lot, even though I shouldn't be using them constantly, but I like to look at my data. So now I've got a browse tool here. So I've got 71 that are matching on this match level 1, but what about all the ones that didn't match? The easy way to do that is to take a join tool, and I'm going to actually connect to the join here, and I'm going to go back to my union and connect over to my left input. So I'm going to do a join here on the record ID, and then I'm going to actually look at what comes out of the left output. So my left unjoined is going to be what didn't join or what didn't match in those 71. So here's my 71 that matched with match level 1. Now I've got 438. It's very important to look at this and make sure, yes, this is prepared and ready to go for another fuzzy match. So I can open this browse in a new window, and now you can actually see here, let me see if I can move that around a little. I've got sources A and B. I've got some large record IDs for B. So yes, this is ready to go, ready for another pass, but I'm going to customize that pass for the second round. So in my first fuzzy match, I used some pre-formatted match styles. These are great. All the algorithms are thought of for me. I don't really have to customize anything like that. So now I'm going to do what's called a waterfall process. And I'm going to add another fuzzy match and say, let's change some parameters here. Let's see what we can do to kind of get that match to be more robust the second time around. So one thing I can actually do is I'll get back here and do the merge only. My source field is source, record ID field is record ID, and I'm going to keep my overall threshold of 80. This gives a wiggle room for everything that I'm matching on, no matter how precise it is in the match style. That match style is going to be 85% or 90% or so on. But for my overall match, with everything coming through the entire tool, I'm going to keep it as 80 so that I have that little bit of wiggle room for all the matches that are happening. So I'm going to go back and do the very same field names. I'm going to do zip code here. I'm going to do address for the next one, first name, and then last name for each of these. But I'm going to keep my match style as custom, and I'm going to edit it this time. So I'm actually going to set up a custom match on this match style. And I'm going to say, let's see, I'm going to pre-process. I'm not going to generate keys on this zip code this time. I'm going to make the maximum key length of 5 because it's a zip code. And then I'm going to say, let's make it a character with a gyro distance. I want to show, as you saw in the Wikipedia, how many turns it takes to get from one zip code to the next. So that's going to allow me to actually now do a different technique to look at zip codes. So I'm going to say, okay, we'll keep the zip codes that way. And now I'm going to change my address one. So now that I've got my zip code set up, I'm going to actually do a very different one for my primary address. So I'm going to keep it as custom. I'm going to strip the punctuation from the address, going to keep it as double metaphone with digits because the address has words and digits in each one. I'm going to say my maximum key length is 8 because really there are only about 12 to 16 sounds there for that key to be generated. And in my match function, I'm going to be words and digits gyro distance. So that way now I'm going to do how many turns does it take between the street numbers to street numbers and the words of the address to the words of the next address. I'm also going to use frequency statistics of US address. And let's see, I'm going to keep that match threshold down at 80%. So I'll keep this one customized. And then I'm going to go into first name and just see what changes I make there. I'm going to, in my pre-process, going to strip punctuation. I'm going to keep it as double metaphone. I don't need digits. I just need the metaphone for how the word sounds. I'm going to generate keys for this word, but I'm not going to generate keys for single letter words. Something to notice when you generate keys for each word is that there's a drop down. So if you've got data that you need to actually remove Ms., Mrs., Doctor, Professor, and so on, or even cardinal directions of your address and commonly used address names, you can actually set that up right here, which is really nice. You can also type your own words. So you can say, don't generate keys for these custom words, which is really nice. So I'm going to keep it here. I'm going to say maximum key length. I'll keep it at 20 on that one. I'm going to say my words are going to be the gyro distance because I want to see those turns. I'm going to use characters with no spaces. And then I'm going to just leave it here. I could say common nicknames for my nickname abbreviation here. I'm going to keep my match threshold a little loose here and my match weight 100%. Or 100 there. And then in the last name, on the very last one, I'll actually change a few parameters on that as well. So again, I'll switch it to edit. I'm going to keep it as custom. I'm going to strip that punctuation again. I'm going to generate keys for the words just like before. Again, a gyro distance here for my words. And of course, if you want to learn more about these, I highly recommend those very cool Wikipedia pages. And then you can experiment and change parameters and see which ones work best for you and for your data. I'm actually going to keep this here on name and actually leave the rest here. So I'm going to say name for this on my frequency statistics, but not a nickname on this one because it is a last name. And then I'm going to change my match threshold down. I'm going to bring it down to 60 so that it has a lot of wiggle room. So a lot of names that are slightly the same but might be different, I'm going to lower that threshold so I can see what happens with it. And be aware that when you lower your threshold, you may get a bunch of matches that actually aren't matches. So it's really important to kind of look through the data afterwards and decide if you need to up that threshold or change some other parameters. I'm also going to output the match score here. I won't output the keys because you saw those earlier. We're going to see those when we join the data back in. And once I have those all set, now I'm going to run that fuzzy match process again. So I'll add a browse tool here. And then run, and we'll see how many match on this one. It's got only one matching on this. So this is, actually I need to change one thing on my first name in custom. I think what happened was I didn't choose name. There we go. So I need to make sure I've got the name value there. And then we'll run again. Should have a few more come through. We just got one. So there are a few parameters that I needed to change in here. Let me make sure I've got it on the custom, on the zip code. I may need to go back to zip code on this one to get that primary address going. Let me check my other parameters for address, gyro distance. So of course it's only during a webinar that this might happen, and now 0. So I am going to go back and switch it back to what I had before. Let's do a custom. Let's edit that. And then let's make sure that we are generating keys for the digits only. And then for the match function. So I apologize for the delay in that. Because to be honest, we really only have in this second waterfall, usually only 7 come through. So it is a second part of the match, but we really only have just a few that come through here for the match. But the most essential part is to show you how the join works after that. Let me get that gyro distance going on. There we go. So we'll get back to the one that is coming through here. So now we have a match on this one with the much more relaxed matches. But once you've done that waterfall process, and again, feel free to change those parameters, then we do the very same that we did before. So we actually add a unique identifier here. And I think we actually don't need to add a unique on this one. There's only one, so we'll skip that process. But we'll do a formula tool here. And we're going to add this one again. And just like before with the formula tool, we'll say this is our match status, or match run. We'll say match status. And then we'll call it 2. And then I'm going to change that to a double. So now we know that's my second run data. So once we've got all this together, now we can union. So we'll go back to the union tool. And I'm actually going to union the data together. So not only what came out of my first one, but here's my match level 1. And that's right, I called it match levels. Let me change that again. And then we got match level 2 coming in here. So again, always check your manually configured fields. Make sure everything's looking right when it's matching up. We do have keys in the first one, but we don't have keys in the second one, so that's totally fine. And then now that we've unioned, we can actually do a join to go back to the original data and look and see what's matching. So this is where the very cool part happens. We're actually going to go to our original data set and then go back to the union. So from this union, we're actually going to pull and go over to the join that we're adding. So let me move that there. And we're going to join first on record ID. So one thing I always show in fuzzy matching is that when you have multiple record IDs, it's important to deselect record IDs as you move forward, or it can get very confusing. So I've got a record ID already. That record ID 2 is for that second data set from 2016. So we'll use that in the next join. But I'm going to deselect this first record ID from the right just because it will be duplicated. So once I've actually selected that, I'm going to show you what that looks like in the first join. So here's my record, 72 here. This is only joining on record ID and not record ID 2. But now I've got my first name and last name, address and zip code, source A. So next I need another join. So I'm going to bring a join here. I'm going to join from the J output of what joined. And then I'm going to go back to that union and join from the union again. So now I'm going to join on record ID 2 to do this. So once I've got my record ID set up, now I'm going to say, give me the record ID for record ID 2. Again, these are already present, so scroll down to your right and uncheck that record ID. And then we'll actually look at the output. So we'll be able to start seeing what's actually joining between the names, between the addresses, and so on. So here I can scroll through and I can say, here's my right name for my last name for source A, and then I have the data for source B. So you can see these are matching up pretty well. We're going to, as we scroll through, see some where there was definitely a match going on for things that were spelled very different from each other. So here I've got like a last name of F. Robinson. It found Robinson, and so on. So a lot of good ones. There's also some that we have, like, let's see, there's some that we can pull in for Constance Avenue. There's some that are like East End, and then you can change and look at the names. So you can start to see the differences. But the best way to look at this, instead of scrolling left and right, is go back into your join tool, and then you can actually move your data. So you can click on this and move it with the up and down arrows to make it easy. So you have a left first name and a right first name. But a tip and trick, you can actually right click and just drag. So I'm just going to right click and drag these and make it easy for me to actually look at each one side by side individually. Go ahead and run that again. And now you can see, I'll actually open the browse tool here to make it a little easier to view. So now I've got these all together. Now I can really start comparing between the two and seeing what really matched. So all these last names with that middle initial, these are all starting to match with each other. And again, in the match tool, you actually do not have to uppercase everything. It will actually do this for you, which is really nice. And the same for street. So let's see if we can find one where the street was actually definitely spelled very differently, and it would actually find a match on those. And a good way of looking at that is actually looking at your match status and your score. So you can actually see the difference between the two. So one of the last things I'll show you here, just in the interest of time, is you can actually add a sort. So now that we have this match status and score options here, where we can actually look at the data for the score and then the level, we can actually sort on that. So I'm actually going to add a sort tool here. And then I'm going to do in the sort, my match level is ascending. I want to look at those that were that first pass first and then the second pass. And then I'm going to do match score in a descending manner. So we'll say match score descending. So this will help us look at the data a little more clearly. So now I've got this score together. I've got my first pass data and then that one record from the second pass data there. But also I wanted to show you very quickly what match keys look like as we look through the data. So here's our match keys. So you can see the number here for the street number is here in the match key. It just generates the number itself for street numbers and for zip codes. But when you look at the names, now you can see how Abby is actually shortened to AP. So it has that sound of just A and the P, which sounds similar to B. And Fitzpatrick actually goes down to these four sounds, FTSP. So Fitzpatrick shortens to these sounds here. Sheridan, or the SH, actually translates into an X. So now you can see Sheraton here in the XRTN. So Dar sounds like a hard T in some languages, so you have a TR. So it's pretty cool how these words are actually changed into these keys using the Jaro and the Levenstein translations. So it's pretty neat to see, how they're actually taking the data and actually pushing this into new translations of words into really kind of a code and using that as your fuzzy match between the two, which is really fun. So let's see if we can scroll over here. We've got sorted by match level. We'll actually sort on match score, and this is match score for the first name, last name, and address. So I'm going to scroll down and look at my match scores and see. So there's a last name. These scores are coming out as 94 down to 85. We did limit it to 85. So let's take a look at this last name and see where these are actually changing. So really those ones that had that extra letter in there for the middle initial, that's where it's actually saying, okay, there's actually something here. These are matching together. So you can see how this match is happening, especially if there's any misspellings. Using the keys that are generated, it will actually find the similarities between the two, which is really useful once you've got that match status. So that's how you're actually doing a waterfall match between each of these. So if you are doing a fuzzy match, you would actually match first, most likely using the pre-programmed match styles, and then you do a join and use the unjoined out of the left unjoined if your data is coming in on the right here. And then what didn't match on that is when you go back and you do another fuzzy match, relax some parameters, see what works for you, and then add a match level after that. That way you can tell what was your first pass, your second pass, your third pass, and so on. At the very end, use these join tools to join back to the original data. It's best to join right after the union so that you have your source information with it as well. And then do the second join. Match first on the first record ID, the second joins on the record ID 2, back to record ID. And again, make sure you do deselect any duplicate record IDs, or your output can get really confusing really fast of which record ID is which. Also, using that sort to sort on match level and how the data is coming out is very useful. So you can see here the match score of last name and so on. And moving the last names against each other so that you can set them side by side and do a real comparison is very, very useful in this data. So I also wanted to say a different trick in fuzzy matching is to not just start here and then start your match and do your unions and so on, but I always just add a join at the very beginning. So I add a join tool between the two. I do remove these here and data cleanse, but I'm going to just do a join after the record ID. And then I'm just going to look at that and say, okay, let's join actually on address. And let's join on first name. Let's join on last name. And let's see what comes out of that. So joining actually allows you to find everything that's perfectly matched first. So I'm going to look at this join here and zoom in. There's 49 that actually match perfectly between the two. If I remove those early in my process, then I don't have to have the fuzzy match tool churn through the data and try to do a match on something that's already matching perfectly. I can already tell between these two data sets of 2015 and 2016, these are already matching. These are continuing customers through the next year. I can go ahead and say, yes, it's a match, remove these from the flow, and then perform my fuzzy match after that. So that's also a really good technique to use in your fuzzy matching. If things are exactly the same, they don't need to be fuzzy matched. So go ahead and take that out of the data stream. So I know we've only got a few minutes left, but I definitely want to open this up for questions. And as always, if I don't get to answer all of your questions, please post them in the chat, and then Rachel can send them over to me and I can answer them individually for you. So again, I'd love to open it up for questions here.
Great. So yeah, we can just cover a few of them. And the first one is, are there any recommended documents to studying Jaro distance and the Levenstein distance?
Yes, absolutely. So not only on the Wikipedia pages, which these are very, very useful, but there are documents out there that you can search for that are actually all about fuzzy matching using these algorithms. So I do recommend reading through these Wikipedia pages first. This should give you a really good overview of how this matching actually works, you know, with the number of turns in the Levenstein distance and so on. And then there's also documentation out there that's actually fuzzy match based. So you can actually search straight for fuzzy match and then the distance metrics, and then really get to know how each one works. And that will really help you customize that second waterfall fuzzy match that you'll perform.
Great. What is the difference between Metaphone and SoundX?
Yes, so metaphone is more how the word sounds based on the actual characters in the data, so it's generating those keys. SoundX is more fluid. So SoundX takes into account international languages and how the words sound. So if you have, say, French names or French location, SoundX is really good to use for that because it really takes into the pattern of the sounds between the letters and how the sounds flow between the letters. Metaphone is more how the characters sound to each other, like that hard C in cat to the K in kite. And that's really where those keys are coming in handy when it generates keys. Also, you can definitely look at those on Wikipedia. There's some great pages about SoundX and Metaphone on Wikipedia also.
So I think we have time for just one more question. When you discover, as in this case, that one of your sources includes middle initial, would it make sense to cleanse that source before fuzzy match so that it's last name only?
You definitely can do that. That may also speed up your process, and that's a really good question because you can just go ahead and add, say, a trim function in the formula tool or something like that to trim off those initials. Or even parse, if you have like a period after the initial and so on. And that might be a little more efficient than trying to run it through fuzzy match and then seeing that, yes, it's a match, but it had a middle initial in it. So cleaning that off would help you do that next tip and trick, which is just do a join to start with and remove everything that matches perfectly first.
Well, great. I think that's all the time that we have today. I will, for the other questions, send those over to Dina so that she can reach out to you guys personally to answer those. Thank you so much for tuning in today. Next week, we will be covering decision tree, so be sure to register for that if you're interested. We look forward to next Thursday.
Excellent. Thank you all very much for joining, and I look forward to talking with you again in a couple of weeks where we do crosstabs and transposes. So thanks again for joining today.